In this video, I'm going to recap the reacTIVision patch that we did in week 4 of our workshop series. So if you remember back, reacTIVision is a piece of software which opens up a window like this, and then we can put in markers that come with the software, and it allows us to track the X and Y coordinates of the marker and allows us to also track rotation. So the reacTIVision software is on the Moodle page and you can download it. And in the reacTIVision software folder, you will also find a Max object called TUIO client. Make sure you double click on that one before you do anything so it's installed in Max. So what I'm going to show you is how to get information from reacTIVision into your patcher and how we can use that to manipulate the playback of some audio. So first things first, once you've got all of that installed and working, you need to create the object and on your keyboard TUIO client. Okay, and this is the object that talks to reacTIVision to get the information of our marker and its position and rotation. So once you've got that, connect up a message box like so, TUIO into the cold input, put a marker on screen and you'll see that we get a message. Okay, we get the word update object, we get a number, and this number is actually a counter, so it counts how many times we put the object on and off. We then get another number, and that is the value related to our marker. So my marker is 67, so you can see 67 in green here, and then we get 67 here. And then we have coordinate data, which is X, Y, and rotation. Okay, so you can see if I go to the top, you can see here, oops, you see here I have nearly 0. If I go to the bottom, then we'll have nearly 1. And then if I go to one side, you'll see the coordinate above it has 0 nearly. And if I go to the other side, you can see it has nearly 1. And then if you look at this value here, and that's our rotation value. So you can see if I move it, it changed the rotation value. Okay, so what I'm going to do, and then when you take the object off, it says remove object 43, which is our counter, and 67, which is which was the mark I was just using. So first of all, this message beforehand, we can use that to filter out the remove object messages because we don't actually need them for what we're going to do. So to do that, we're going to use the root object, and as its arguments, we're going to put update object and remove object. Okay, and we're going to hook that up like so. So what this is going to do is when a message is received that starts with update object, it will output the rest of the message here, and you can see it says outputs if input matches update object, and if the input going into this object says remove object, it will come here and it says outputs if input matches remove object. So this is a way for us to route the information according to whether it's an update object bit of information or a remove object information. So let's just see if that works. So just connect up a message box like so. Excuse me a second, I'm just plugging my laptop in. Okay, so connect up your objects like so. So you've got the root object going into the cold input of a message box. Put a marker in front of your camera, and you'll get the message without the remove or update message before it. If I put one here, you'll see that when I put the marker in front of the camera, you'll get the coordinate data. When I remove it, you'll get the remove data. So we don't actually need the remove data for the second, so we can just delete that. Cool. Now actually, in here, we've got a counter first. So this value here is actually a counter, and that tells me how many times I've put an object on and off screen. So 47, 48, 49. Now we don't actually need that piece of information, but if you were going to have lots of markers that were the same, then you would need that piece of information so you could identify them. So we need to get rid of that, and to do that we can use the object ZL slice, And what this object does is slices a list into sections that's denoted by an argument. So if we put ZL slice 1, after the first element of the list, it will slice the information and send it out of this outlet, and the first bit of information will come out of here. So this will take off that first value in our list. So just to show you, so we got our counter here, and then we have our marker values here, like so. Okay, and we don't need the counter in this instance. So now we want the ability to be able to route different objects when we put them on screen to different places in our patch. So for example, if I put 67 there, I want that to go to one place, and if I put 42 on here, that can go to another place. So they can be controlling different things. Now to do that again, we use the same object that we've used up here. So we use the root object. So as its arguments, you put in the IDs of the markers that you're using. So I'm using 67 and 42. And we hook that up like so. And now when I put 67 on, we'll get the data here. And when I put 42 on, we'll get the data there. And you can put them both on at the same time, and it will separate the data for you. Okay, so that's how you make sure that you can separate individual objects and get them to control separate things. So this root object, all it's doing is listening to the arguments that you've given it, and when it receives like a 67 in this case, it will output the information out of this outlet, and when it receives 42, it will output the rest out of here. And you can put multiple arguments in here, and it will create an extra outlet for each argument. Highlight those two and delete them. So now what we want to do is we want to use this information from these markers to do something for us, and we're going to do a bit of audio playback and manipulation. So what we need to do is basically we just want to use the first three elements of this information coming in, okay, which is our X, Y, and rotation coordinates. The other values here, so we just need this one, and this one. The other values here are all related to speed, and we don't need to use those. Okay, so if we use an unjoin object, unjoin 3, oops, this will take the first three elements of the list and output them as individual elements here, here, and here, just giving us the values that we want to use. Okay, and just to show you, again, we put 67 on the camera, you'll see that we'll get those values. Cool. So delete those message boxes, and now we're good to get the audio playback working. So the object we're going to use here is groove. Okay, and the groove will need a buffer. So we need to load the audio into a buffer, and we need to give groove the name of the buffer as an argument. So I'm going to call my buffer loop. So once you've done that, create a buffer object and give it the argument loop. Okay, and then to load in audio into our buffer, I'm going to use, so message box M on your keyboard, I'm going to use the replace message, and that goes into our buffer object. There's a difference between the replace and the read messages. The replace message resizes the buffer's length, its memory, to the size of the audio file that you're loading in, where the read doesn't. So the read message will just load in the audio, and if the buffer's not long enough, then it will cut it off. So if you want to have the whole sample, always make sure you use replace. So click on your replace message and load up a loop that you want to use, and then double click on your buffer object to make sure it's loaded in. Cool. Okay, now we can put our buffer to one side and we can start working with our groove object. So this is an object that allows us for audio manipulation. Okay, so first things first, we need to be able to hear what's coming out of it, and for that we use the DAC tilde object, and we give the arguments 1 and 2, which is our left and right channels, and we hook up groove like so. And then if we create a toggle, T on your keyboards, and hook that into the inlet of DAC, we can then turn our audio, as you can see down here, on and off from within our patcher. Now the groove object needs to be fed a signal value to tell it how fast to play back. So if we send it a signal value of 1, it will play back at normal speed. 2, twice the speed. -1, reverse normal speed. -2, reverse twice the speed. So to create a signal that's going to drive our groove object, we need to use the object sig, tilde, hook that into the inlet of groove, and this object basically just creates a constant signal of a value that it receives into its inlet. So if we create an integer box I on your keyboard and hook that into the inlet, if I put 1 there, that 1 will go into the signal object, and then the signal object will create a constant signal value of 1 going into the groove object. Cool. Okay, so there's a few other bits that we need to do to get this working properly. So we also need to put in a message object to get this one to loop. So if you create a message object and type in loop 1, put that into the inlet of groove, and when you lock your patches and press that one, it will turn on groove's looping function. Okay, so that just allows us to make sure that groove is in looping mode. Without loop turned on, when it gets to the end of the audio sample, it will stop. Cool. And then finally, we need one more message box, which we're going to put 0 in, and this tells Groove where we want it to start audio playback. So I want it to start at 0 milliseconds. If you put 1000 in there, it will start 1 second into your audio file that you've loaded into the buffer object. So press 0, message box with your patch locked, turn the audio on, and you should be able to hear the sample. Okay, you can't hear it on my computer because I'm plugged in with headphones, but you can see the audio is coming out here. So I'll just unplug my headphones so you can hear it. Okay. So now we've got that working, it's pretty straightforward. All we need to do is get each one of these 3 data elements to control different parameters of this. So let's start with this coordinate here. So let's just grab a marker. So it's got to be 67 because I'm hooked into the 67 outlet. So grab a marker, put it in front of the camera, and you can see on this one, it's our x coordinate. So if I go to one side, it's nearly 0. And if I go to the other, it's nearly 1. What we're going to do, and what we did in class, was use that to control panning. So we're going to do that here as well. So panning can be just seen as basically a volume control for independent channels, so for your left and right channel. So we can put the pan controls in here. So if you delete these 2 cables, and to control volume in max, we use a signal multiplication object. Okay, and this signal multiplication object basically will take a signal that comes into its inlet. In this case, it will be the output of the groove object, like so, and it will multiply it by a value that comes into this inlet. So if it receives 0, it will multiply the signal by 0, which means we won't hear anything. If it receives 1, it means we'll hear it at the normal volume. If it receives 2, it will be twice the volume, so on and so forth. Now this data range here is already 0 to 1, so this works perfectly for audio volume, so we don't actually have to manipulate the data at the moment. Okay, so if we hook one side of this into here, okay, so this one goes into one side of our signal multiplication object, and this is going to be our channel 2. Okay, now we need to invert this value here so it does the opposite for the other channel. So obviously when this is 1, we want this to be 0, and when this is 0, we want this one to be 1. So if we Control C, Control V that one, groove object into this one too, connect that into the DAC, and then to invert this value, if we create a scale object, so the scale object takes a scale and then puts it into another scale, So the range at the moment is 0 point to 1 point, and we want it to be 1 point to 0 point. Okay, so this is the old range and this is the new range. So this will just invert it for us. We connect that up like so, and then that one goes into our other channel. And now, if I unplug my headphones, turn this on, put marker 67 on the screen. Have a look down here, it's probably best. If I go to one side, you can see that this side has got the audio up the loudest. And if I just quickly move it to the other side, you can see it's the opposite. So our pan control is working. Turn that off. Cool. Okay, so next we've got our pan control, left and right position controlling our panning. So now we probably want to have our Y, which is our up and down, controlling overall volume. So the higher we put the marker on the camera, then the higher the volume. Okay, and this is exactly the same as we did in the session in class. So to do that, it's a pretty similar process to what we've just done. So if you delete these two cables, and basically we just need to create another two multiplication objects. We connect those two into our DAC, and then we take one feed from our pan control into our volume controls, and then both of these simply go into here. Okay, so this is our Y coordinate and it just goes straight into the signal multiplication. But you'll notice, so again, if we just turn that on, go to here, if I put my marker in, when I go to the top it gets quieter, and when I go to the bottom it gets louder. Now that's a bit counterintuitive, so what we probably want to do is invert this as well. So if we delete these two cables, copy and paste our scale object, which is inverting the data for us, hook that up like so. Okay, so just maybe move these so it's nice and tidy. And if we pop that then into here, and then again into the other side, we should then, if I go higher, it gets louder. If I go down to the bottom, it gets quieter. Cool. So that's controlling our pan, and we're also controlling our overall volume. Now finally, we have a value coming out of here, which is our rotation, and we can get that to control how fast our playback is. Okay, so if you delete this object, because we don't need it, and let's have a look at what values we get out of here. So put your object in front of the screen, rotate it, and you'll see it will go from 0 all the way up to, when it gets to 360 degrees, 6.28 it should be. Okay. Now you don't need to worry about what that 6.28 means for the second. All we need to do is scale that into a range that can control our playback. So if we create another scale object and put 0 point to 6.28, because that's the range that our data is coming in at, we put space, and we want that to then say to go to 1.5 times the speed reversed to 1.5 times the speed forward. If we put that in to our signal object and then connect, so we can delete this message box and connect that up like so, turn on our patch, put your marker in front of the camera, and as you rotate, you can control the playback speed. Cool. So that's basically what we did during the session as a cut down version. If you wanted to then have a different sample, all you had to do is Control C, Control V this, so copy paste this across, and then out of here, this one goes into here, and then 42 will control this bit and 67 will control this bit. Now when you do that, obviously you have to create another buffer and change the groove name if you want to have a different sound playing. Cool. If you have any problems, let me know and I can run through anything with you one-to-one, or we can arrange a tutorial.